Hi, good morning. This is Sunil Kumar Badu. In the previous lectures, we have seen computer networks definition, and then ISO OSA model, and then types of topologies, and then CSMA. Now, today I want to discuss about classful IP addressing. What is meant by classful IP addressing? First of all, what is IP address? IP address is used to identify a system which is connected in a network. IP address is IP address is used to identify system which is connected in a network. In a network, so many systems are connected. To identify a particular system in a network, IP address is used. This is a 32-bit address. IP address is 32-bit address. It has 4 octets. 32 bits are present in the IP address. It has 4 octets. Classification of IP address. These IP addresses are classified. How these IP addresses are classified into two groups: classful IP addressing, classless IP addressing. Classless IP addressing is also called CIDR, classless interdomain routing. First of all, go through classful IP addressing. Introduction to first we need to see the binary number system before going to know the classful IP addresses. For introduction to binary system: bit, byte, kilobyte, megabyte, gigabyte, terabyte, and petabyte. 1 bit means 0 or 1. 0 comma 1 is called 1 bit. 1 byte means 8 bits. 1 kilobyte equal to 1024 bytes. 1 kilobyte equal to 1024 bytes. That equal to 2 power 10. 1 megabyte equal to 1024 kilobytes. 2 power 20. 1 gigabyte. 1 gigabyte equal to 1024 megabytes. That equal to 2 power 30. 1 terabyte. 1 terabyte equal to 1024 gigabytes. 2 power 40. 1 petabyte. 1 petabyte to 1024 terabytes. 2 power 50. These are binary systems. These are binary system. Next, IP address. IP address is 32-bit address. This IP address can be classified into 5 different classes. What are those? Class A. With the first bit of the binary number system is 0. It is class A. Class B. Class B means first 2 bits are 10, that comes under class B. Class C. If the first 3 bits are 110, it belongs to class C. Class D. First 4 bits are 1110, then it belongs to class D. Class E. First 4 bits are all ones, then it belongs to class E. These are classes of IP addresses. Class A comes under 0 to 127, class B 128 to 191, class C 192 to 223, class D 224 to 239, class E 240 to 255. Class A, if the first bit is 0, then it comes under class A. If the first 2 bits are 10, then it comes under class B. If first 3 bits are 110, it comes under class C. If first 4 bits are 1110, it comes under class D. If first 4 bits are all ones, it comes under class C. Here is the diagram for know the classes. If the first bit is 0, it's class A. First bit and second bit is 10, it comes under class B. This is the diameter representation. Now here some of the examples are there. Find the classes of each addresses. First A. If the first bit is 0, then it comes under class A. If first bits are 110, first 2 bits are 1, third bit is 0, this class C address. If the first 2 bits are 10, then it comes under class B. Next D. If all bits are 1, it comes under class C. Class A 0 to 127 class A, 128 to 191 class B, 192 to 223 class C, 224 to 239 class C, 240 to 250 class C. Class A address. First we need to know some of the class A. In IP address, net ID and host ID are there. Total 32 bits. Net ID means network ID. Host ID means it is used to identify host in a system, in a network. Now class A, first byte is used for net ID. Remaining 3 bytes are used for host ID. In class B, first 2 bits are used for net ID. Remaining 2 bits are used for host ID. In class C, first 3 bits are used for NAT ID. Remaining 1 byte is used for host ID. In class C, it is used for multicasting. In class C, it is used for reserved for future use, research purpose. In class A, first byte is used for NAT ID. Remaining 3 bytes are used for host ID. In class B, first 2 bytes are used for NAT ID. Remaining remaining 2 bits are used for host ID. In class C, first 3 bits are used for host ID, NAT ID. Remaining byte is used for host ID. In class D, multicast addressing is used. Class C used for research purpose. Class A address. What is class A address? First bit is used for identifying class A. First bit in the IP address class A, 4 bytes are available. 4 octets are available. In 4 octets, first bit is used for identifying class A. Total number of networks present in class A is 2 power 7 minus 2. 2 power 7 minus 2 equal to 126. 126 networks are present. Total number of hosts is 2 power 24 minus 2. How? In class A, first 3 bytes are used for host ID. First 3 byte means 3 into 8, 24. So 2 power 24 minus 2. These two are used for special purposes. That's why it is subtracted from 2 power 24 minus 2. These are host addresses. In total 126 networks are there. In each network it has 2 power 24 minus 2 IV addresses. Total 126 126 networks are there. Each network has 2 power 24 minus 2 addresses. 2 power 24 minus 2 addresses. It is nearly 16 million addresses are there. In each 126 networks are there. In each network 16 million addresses are present. This is class A address. 2-bit special IP addresses are present. 0.0.0 DHCP client 127.x.x.x. It is loopback address. 2 IP addresses are reserved for host ID. In the host ID, two addresses are subtracted 2 power 24 minus 2. These two are used for network address, and it is also used for another one is used for broadcast address. Understand? Once again, I am repeating. First bit is used for identifying class A. In class A address, first byte is used for NAT ID. First byte 8 bits are used for NAT ID. Total are 8 bits. 2 power 7. First bit is used for class address. So 2 power 7 minus 2. 126 IP 126 network addresses are present. In each network 2 power 24 minus 2 addresses are present. So for these 2 bits are special IP addresses. 2 bits are special IP addresses. 0.0.0 DHCP client. Another one is used for loopback address. That's next one is 2 IP addresses are reserved for host ID, network address, and broadcast address. Understand? Total 120 in class A, total 126 networks are there. In each network 16 million addresses are present. 16 million means 2 power 24 minus 2 means 16 million. 2 power 24 equal to 2 power 4 into 2 power 20, 16 million addresses are present. Coming to class B IP address, 2 bits reserved for identifying class B. 2 bits are reserved for identifying class B. Total number of networks are 2 bytes are used. 2 bytes are used for NAT ID. 2 bytes means 2 into 8, 16. 2 bits are used for class identification. So total number of networks are 2 power 14. 2 power 14. So total number of hosts. Total number of hosts, 2 bytes are used for host ID. 2 power 16. 2 bytes means 16 bits. 2 power 16 minus 2. Total number of hosts are 2 power 16 minus 2. In class B, 2 power 14 networks are present. 2 power 14 networks are present. In each network, 2 power 16 minus 2 host IP addresses are present. 2 power 16 means 64,000 IP addresses are present. Nearly 64,000 IP addresses are present in each network. In a class B address. In class B address, 64 million 64,000 addresses are present in each network. 2 IP addresses are reserved for host ID, network address, and broadcast address. Coming to class B. In class B, 3 bits are reserved for identifying class C. Total number of networks are in class C network, 3 bytes are used for NAT ID and 1 byte is used for host ID. 3 bytes means 3 into 8, 24. 3 into 8 24. 24 minus 3 bits are used for host ID. So 2 power 21. 2 power 21. 2 power 21 networks are present, and total number of hosts are 2 power 8 minus 2. Total number of hosts, how in host ID, 8 bytes are used for host ID. So 2 power 8 minus 2. 2 power 8 minus 2 addresses are present in class C address. Total two IP addresses are reserved for host ID, network address, and broadcast address. And coming to class D. Class D used for multicasting. For multicast means some group of group of for some group we need to send some we need to send a message to some group. For that, class D addresses are used. 4 bits reserved for identifying class D. Total number of networks is 0. Total number of hosts are 2 power 32 2 power 32 minus 4, 2 power 28. Total 4 bytes are used for host ID. 2 power 32 minus 4, 2 power 28. Class C, 4 bits are used for identifying class C. Total number of networks is 0. Total number of hosts are 2 power 32 minus 4, 2 power 28. Class C is used for research purpose. Find the class of each address. Here some IP addresses are given. Find the class of address. How to identify class C? In class A, 0 to 127. Class A, 127 to 120. 120 class A, 0 to 127. 128 to 119, 191. Class B, 190 to 223. Class C. Class D, 124 to 239. Class D, 240 to 255. We have already seen in this slide. Class A, 0 to 127. Class B, 120 to 191. Class C, 190 to 223. Class D, 224 to 239. Class E, 240 to 255. By using that table, we have to identify the we need to identify the IP addresses. Another method is converted into binary system, and then it is also by using first bit, second bit, third bit, 3 bits, 4 bits. We easily identify the classes of IP addresses. These are class A for IP address: class A, class B, class C, class D, class C. First byte is used for NAT ID. In class A, first byte is used for NAT ID, and remaining 3 bytes are used for host ID. In class B, first 2 bytes are used for NAT ID, remaining 2 bytes are used for host ID. In class C, first 3 bytes are used for NAT ID, remaining byte is used for host ID. In class D, used for multicasting. Class C used for research purpose. Millions of class C addresses are wasted. Class C address. How many IP addresses are present in class A? In class A, total number of hosts are 2 power 24. 3 bytes are used for host ID. 3 bytes means 3 into 8, 24. So 2 power 24 minus 2 IP addresses are present in each network. How many networks are present? 126 networks are present. So each network has 2 power 24 minus 2. That means 16 millions. 16 million IP addresses are wasted. So millions of class A addresses are wasted. Coming to class B, many class B addresses are wasted. In class B also total 64,000 IP addresses are present. These are also wasted. The number of addresses in class C is smaller than needs of most organizations. In class C, how many addresses are present in class C? Only 254 addresses are present. 254 IP addresses are present. So it is very useful for many organizations. Class C addresses are used for multicasting. There is only one block in this class. Class C addresses are reserved for future purpose. Most of the block is wasted. Special IP address. Special IP address. How to identify special IP network address? If the network address is NAT ID specific, host ID is all zeros, source of destination none. Direct broadcast address specific all ones. Limited broadcast address all ones, all ones. This host and this network all zeros, all zeros. If all zeros are present, it belongs to this host on this network. This host on this network. The network this particular host is identified. These loopback address means 127 dot any 127 dot x dot x dot x. This is loopback address. These are special IP addresses. Next address of private IP networks 10.0.0. This is private address 172.16 to 172.31. These are another private address 192.168.0 to 192.168.255. These are another IP address. These are private IP address. These private IP addresses are used. Internet assigned naming authority. Number authority IANA is authorized for giving IP addresses. IANA internet. Okay, thank you.